All right, hey you guys, we are doing SAT lesson number 7 today. This is percentages. This is part 1. So in my experience as an SAT prep teacher for the past many years, percentages is a topic that I can't recall ever being taught in high school math. Maybe you did a very brief introduction of it in some very low level math class, maybe when you were in junior high. But the SAT always asks several questions that have to deal with percentages. So I've divided my lesson into 2 parts. I'm going to talk part 1 today, which is basic intro percentage stuff, to remind you of like some common sense things and some basic principles and ideas about percentages. And then I have a part 2 lesson also that I'm going to make a different video for, which is some more elaborate, more complex questions applying stuff from this video. So I'm starting with a couple very basic common sense uses of percentages. What's the tip? Here's the bill for lunch, and you're supposed to leave a 20% tip for the waitress or waiter. And we are taking the total and we are multiplying by 0.2, and that is the tip. Maybe some of you guys are servers, right? Maybe some of you work at at Starbucks and you hope for tips or something like that. How much can you expect if you did good service and you're expecting 20% of the total bill, which means you get $3.09. What do you do if you're paying this money? Then you take your dollar amount, which was your lunch, and you add the tip to it, and that's what your credit card gets hit for, right? What's my score on the test? You got 41 out of 45. How do we figure out what percentage that is? Well, you divide 41 over 45. In your calculator, it gives you a decimal, and you convert it into a percent, and that is your percent score on your quiz or your test. You're going on a shopping spree, and thank goodness in the mail you got a 15% off coupon to Sephora, and you're super pumped about it. So you take, or you want to buy a sweatshirt. Okay, so we're going to Lulu or something like that, but we want to buy a sweatshirt. It's almost $50. It's $48.99, but you have a 15% coupon. That means that you multiply your 0.15. Notice how I'm always changing these percentages to decimals, but you're taking your 0.15 and multiplying it by the price of the sweatshirt, and that means that you save this much money. It's $7.35 off. That's not what you pay. That would be a hell of a coupon, right? But you're saving $7.35. So to figure out what your total price is, you take the original price and subtract what you're saving. That gives you your new price, okay? Hopefully you're thinking to yourself, duh, I already know this. Okay, fine, I can do this. That's great, but the SAT will kind of twist and turn these basic concepts just a little bit. So it's good that you're very comfortable, hopefully, with those strategies, okay? I have a formula for you. I learned this, I feel like, when I was in middle school. The percent over 100 is equal to the is number over the of number. I will refer to that when I do these 2 questions, but that's just a basic proportion you can set up to solve percentage questions. And then remember, you just cross multiply, cross one way, put the equal sign, and then cross the other. And then for percent increase and percent decrease, there is a formula that you can use, and I will also talk to you about tricks when we look at some percent increase and percent decrease questions. Make a note, always use the decimal form of the percent. But what you're doing is you're taking your new price, if that's what you're trying to figure out, then it equals the old price plus the percentage times the old price, and make sure that that percentage is in a decimal form. And there is a trick. You can just take 100% and add it to the percent increase and multiply that as a decimal by the new price, by the original price. I'll get to that when we get when we do an example. But for percent decrease, your new price is always, it's the exact same formula. Notice how it's just a plus sign that changed to a minus here. And what you can think about with some common sense in terms of percent decreases, you can think about what percentage is remaining, and you can multiply by that percent as a decimal. Again, I'll talk about that when we do more examples, okay? And dealing with percentages here, it's just a combination of trying to use some of these formulas. You kind of piece together, use some of your tools in your mental toolbox, and try and keep some common sense in mind as well. I'll get to some common sense thoughts when we get to some of those questions as well. So let's go. Number 1, what percentage of 300 is 75? Very basic question, but what percent means I'm putting x over 100. Remember, this formula right here is what I'm using. The percent I don't know, so that is where I put my x over 100. And the 300 is the of number, so that goes here. Notice it's on the denominator. These are in alphabetical order. If it helps you, is goes on top of. And then the is number is 75, so that one goes here. So you plug in all of those numbers and then you cross multiply. When you cross this way, you get 300x. When you cross this way, you get 7,500. Divide by 300 and you get 25, okay? I've got another very basic example using that same formula. 432 that's my is number, so that goes here. 96%, that goes over 100, that's the percent. Of what number means I'm putting an X where the of is, so that's down here. Okay, so you can just take some of these questions and just plug in the numbers to the right spot, and you can cross multiply, you get 96x this way, keep your equal sign in the middle, and then when you cross this way, you get 43200, divide, and you get 450, super. Let's look at number 3. You have 900,000 beads. What are you doing with 900,000 beads? I don't know, and nobody cares, but 828 of them are silver. So let's think about common sense here. What percentage are silver? Think about this. Let's use some common sense. Yes, I'll talk about this and how to get the correct answer. However, almost all of them, would you refer 828,000 out of 900,000 as almost all of them? Our silver, 8%, that's definitely too low. 36, that's definitely too low. Even 72, that's definitely too low. Without knowing anything about percentages, you can probably guess the right answer on this one just by noticing that 828,000 is almost all of the 900,000 beads. Okay, without having to do anything about formulas. Unfortunately, some of these high school students have gotten very lazy, and they will see a question about this and see the word percentage and be like, oh, screw that, I don't know how to do percentages, I'm just going to guess. I'm going to guess C because I guess everything C, right? You probably know someone who might think like that. Let's not be lazy, and let's try and use at least common sense in reading through every question and giving yourself the best possibility of getting the correct answer. This is kind of like a test score. If there are this many questions, that would suck. But if there were that many questions and you got this many right, you take your number correct out of your total, right? So this is the fraction that gives you exactly 92%. Super. Let's go to number 4. I have 2 different ways to kind of attack number 4. A very basic problem. We have an original price and then we have a discount. It's the same thing as like having a coupon or whatever. You're saving 20%. What is the sale price of the jacket? So what's the price of it on sale when the original price is $50? Okay. People who are really, really great at decimal or at percentages and can do stuff like this in their head, like my husband, something that's reduced by 20% means that you are paying for 80% of the jacket. Does that make sense? When you don't have to pay for 20% of it, that means you're only paying for 80% of it. 20 and 80 add up to the original 100%. So shortcut trick, you can take 0.8 and multiply it by $50 because that's the original price of the jacket, and that gives you $40. That's how much you pay. 20% off means you're only paying 80% of the jacket. 80% of $50, $40, there's our answer. What if you are a formula person, or if you were thinking about, okay, how much money am I saving? If you take your $50 and multiply it by 20%, which is here, that means that it's $10 off. Okay, so you save $10, or the store gives you back $10. So take your 50 and subtract your $10, and you still end up with 40. 2 different ways to think about percentages, but the faster, quicker way that people who are really great at mental math will be thinking about is if something is reduced by 20%, that means that you're taking your original price and paying 80% of it. All right, number 5, what number is 40% greater than 115? If you were trying to do the is over of and percent over 100 formula that we did on questions 1 and 2, the difference between this one is it's a 40% greater question. That implies an increase or decrease, which is not just a straight up what's 20% of 50, okay? So this is a little bit different, and I'm also not sure where I would put the is number. There's no of. It just doesn't work for this question if that's what you were thinking. It's actually an increase question. What is 40% greater than 115, which means you're taking 115 and you are increasing it 40%. Okay, so people who are really great with percentages are going to take the 115 and they're going to think to themselves, okay, I'm paying 100% of the 115 and I'm paying 40% more. That is why when you add those 2 percentages together, you get 1.4. And that means that we're now paying $161. Or I don't know if this is dollars, it's just numbers, but whatever. So make sure if this is a multiple choice question, remember some answers are multiple choice and some of them are type your answer into a box. Maybe if this were a multiple choice question, you could eliminate some numbers that were less than 115 because you know that you're trying to increase the 115. If you're a formula person, this is the formula that I would use. You start with your original price, which is 115, and you are adding, because it's an increase, 40% of the 115, and you still get 161 when you do that. If you're a formula person, original plus percent original, that is your formula for increase. And the only thing that changes if it's a decrease is you change that to a minus sign. Okay, and we get 161, but more quickly and common sense looking, we're taking 140% of 115. It includes the original 115 plus 40% more. So we're going to multiply that by 1.4. All right, how about number 6? A number n is increased by 6%. The result is 318. This is the answer. This is after the discount, okay? So we're taking a number n. I don't know what the number is, but I am increasing it by 6%, which means I have the 100% of the original number plus another 6%. That means I'm multiplying by 1.06. It's 106% converted to a decimal, 1.06. I don't know the original number, but I'm increasing it by 1.06, and I know that the answer is 318. Okay, now I can just divide both sides by 1.06 and get 300, okay? I know this answer is incorrect because I increased a number 6% and the result was that after the increase, which means I didn't have a decrease, so I can eliminate this number. If you're a formula person, let's talk about that. I don't know the original number, but I know I am increasing the original number by 6%, and I know that the result is 318. When you combine these like terms, there's really a 1 here in front of the n, right? So you can combine those like terms and get 1.06n. And again, look, this is exactly what we had written here. You're just dividing both sides by 1.06 and you get 300. Okay, last year Cedric had 35 plants in his garden. This year the number is 60% greater. So again, we're doing an increase here. That means he is having 100% of his original plants plus 60% more. So I'm taking the original number and I'm multiplying it by 1.6. That means now he has 56 plants. How about this one? If you're using a formula, you have your original amount plus 60% of the original amount, and we still get 56, okay? Whichever way you want to think about it, hopefully you're starting to feel a little bit more confident with percentages, and this is maybe making a little bit of sense to you. It's like, oh, okay, if it's a 60% increase, so we just multiply by 1.6. Great. If you're a formula person, which I am, I like to plug in my numbers and do the same thing every single time. That hopefully will work for you as well. I've got one more in this basic lesson, and then I'm going to flip over to the part 2 lesson, okay? So stay tuned for that. But we have a cost of a shirt, which is $20 before we have a sales tax added to it. So you guys know that tax always makes your price go up just a little bit. In this case, we have a 5% sales tax. What is the total cost? You got to pay for the $20 plus the tax, okay? So what is the tax that we have to pay? You can just take 5% of 20, which is this, and that crunches out to just $1 for tax. But since it's asking for the total cost, then that means that your $1 gets added to your 20. So now your credit card gets hit for $21, okay? If you want to think about more of a quicker, faster trick route, then take your $20 and multiply by 1.05 because you have to pay 100% of the shirt plus an additional 5% sales tax. That's a shortcut of doing this over here is just taking the 20 and multiplying by 1.05. Either way you look at it, you got $21, okay? Thanks for watching, you guys. Stay tuned for part 2. I'm going to advance some of these concepts just a little bit. And again, if this made 0 sense to you, I went way too fast, you need some serious help with percentages, that is totally cool. Come see us on a Friday. Don't forget about that, okay? We can do this.